12:05.
Oh, 12:05, yeah. Do Thursday, yeah. Yeah.
On 12/4, page 752 in the homework.
Yeah.
Question number 40. This is factor that. And I thought you pulled the 3 out because the
Oh, she did leave.
is power. No, she had, yeah. Because 3 is the power. So I was looking at it that if R to the third, and then you look at, I was thinking you could pull it out.
Definitely not.
That's not how it works. Okay.
So tell me this.
Is that R plus S or R plus 5? I'm sorry.
R plus S. So if I had A plus B squared, is that A squared plus B squared?
No.
Hell no, right? So a power cannot distribute across a sum or a difference, right? Because powers are based on what operation? Multiplication. So if I had A times B squared, then all day long I could write that as A squared B squared. Because powers are going to work well with multiplication, because they're based, that's what powers are based on, right? So why the hell am I talking about powers when you have a root? Because roots are powers. So this is R cubed plus S cubed to the 1/3. You can't distribute the 1/3. Same reason why you can't distribute the 2. Yes, sir.
The quick question is, how do you get to the 1/3 though? Like, how do you even get to that? That's what
Okay, all right. So like we were saying earlier, cube root of x. How can I rewrite that? It was the whole. Is that x to the 1/3? Yeah. So this is something I was assuming we all understood.
No, okay, just one. If it's like the cube root of 5, so it's 1/5, it could be even that. You get what I'm saying? If the 3 is a 5.
No. The fifth root of x would be x to the 1/5.
Yeah, that's what I'm saying. So
All
okay,
right.
makes sense.
Okay.
Perfect. Thank you.
So you can't say something like square root of 4 plus 9 equals 2 plus 3. That's a very common mistake. Do you see why somebody would believe that? Some of you guys might be looking at it saying, yeah, that's me, I believe that. What the hell? Because square root of 4 is 2, square root of 9 is 3, Jeff. What the hell? Sorry. That's not right. It can't be right. I can't distribute. So this is 4 plus 9 to the 1/2. And I know I can't do this. I couldn't even FOIL this. How do you FOIL this when it's 1/2 of this? If it was squared, I could write it twice. But now you got to write it half. So you just write the bottom halves plus 9. That's weird, right? So I can't distribute the 1/2 because it's addition. Addition doesn't work well with roots, which are also powers. So, I mean, this problem, of course, would be easy. It's not 5, that's crap. Square root of 13, which is not equal to 5, right? So I can't use a root across a plus or a minus. I can't. They don't play well together because they're not based off of each other. So what the hell do you do then? They're both cube roots. So can you cancel an R and cancel an S?
No.
Hell no. Why not?
Because it's addition?
Because it's addition. And division will not cancel any parts of addition. Division will cancel... What will division cancel? Multiplication. Be quiet. So if I could rewrite this as a product, which of course another way to say that is factor that. Because that's what factoring does. It writes things as products. Then I can possibly cancel something, right? And what is that? What form is that in?
Division?
Cubes.
I'm
Cubes!
sorry. Yes.
So how do you factor this top here? Little dude, big dude. I like it. What's going to be the little dude? R plus S. And hey, look at the bottom. That's craziness. Eventually these are going to cancel. Of course, what's left in the big dude?
R squared plus RS or minus?
Minus RS.
1S, so there's got to be 2 S's. 1 of each, 2 of each product in the middle. That's the closest to a sum I'll ever get. Can't even write. Yes?
I don't know why I totally blanked out and forgot how to keep the middle part of big dude and
I don't know. I'm sorry.
but can you re-explain? You got
So the middle dude is always the product of what's in the little dude. Right? Middle dude is the product of the little dude.
So I don't put R plus S.
Nope. R times S. Whatever's in here, product goes there. Whatever sign this is, has to be the opposite, because he's the cleanup dude, right? He's the dude that cancels the stuff I don't want. We did that a while back.
And I don't put any sign.
Oh, in between these? No, the product. So you multiply, so you just need them to sit next to each other. Now, what am I allowed to do for the end result here?
Cancel.
Yeah, these both have cube roots, so I can cancel these parts. So I'm left with
R's.
our cube root of r squared minus rs plus s squared. Done. So there's a problem with the test where you had like a square root on the top and a square root on the bottom. A lot of you guys did some weird, this would work. You simplify the top and bottom, but it's so much easier. They're both square roots. Cancel. If they're both the same root, you can multiply, you can divide. So if I had the square root of 250 over the square root of 10, I'm going to cancel the zero. It's going to make it square root of 25. That's easy. Yes, ma'am.
So even though on the top they're both under the same square root, you can just cancel one of them?
So again, I can rewrite this as one big ass cube root of everything.
Okay.
Just everything is in a cube root. So that's sort of like, I'm not really skipping this step. This is just a little bit more visually explanatory, right? I can make all these two separate cube roots. I can make it a one big cube root. And then, of course, you can see those totally cancel. Yeah. Or I can split the cube roots apart. And this cube root and that cube root cancel, and that's still in a cube root. Whichever way you go, it's going to work.
So the only time that you couldn't cancel if it was like...
Different roots. If this was the fourth root,
Right, okay.
nothing I could do really. Yeah.
Okay.
Okay. Yeah.
And you don't break that down anymore. You can't take the cube.
Yeah, the big dude, well, yeah, I can't take a cube root of this because I can't even factor this anymore, right? I can't break this up at all to see if it's got 3 of anything because I can never factor the big dude. Never waste time trying to factor the big dude. Just leave the big dude alone. Yes?
I have one more. The one that was 30. Did you have
Where are we at, sir?
on the same homework, number 35?
So that's like the one I was just talking about. So 35 says...
Square root
What is it?
180
Okay.
over 5 square root 2. So then I took 10, and the square root of 100, I made it 10, 80, and then I left the 5 and the 2 alone.
Yeah, okay. So you got 10, and then what happens with the rest here?
80.
So how did the AB
Does it?
not get affected by the square root? Okay, so square root of 100 now, so I can take this and I can break it up into square root of 100 times square root of AB.
Okay.
Right? And then the square root of 100 is 10. The square root of AB is?
Square root of
I have no idea.
Okay.
Yeah. And then you can cancel it. Right?
I divided the 5 into the 10.
Yeah, beautiful. Reduce that. Yeah.
Yeah, and then we left with the 2. Was it 2 on the top or the bottom?
Well, 10 divided by 5 is 2 over 1. If it was 5/10, then that 2 would be down there.
Oh, okay.
Yeah.
Okay.
Now there is a little something here.
So that's the fundamentals you said?
Sort of. I'm going to talk about something that's related to this.
Okay.
This thing called rationalization. Right? So this is not only psychology class, if you know rationalization. No. So what rationalization is all about is it normally is involving the denominator.
This is new stuff?
Sort of. This is something from 12.4 that nobody asked me about, but I'm going to go back and talk about anyway. So square roots are kind of gross by themselves. I think you'd agree with me, right? Square root of 2, gross. Grosser than it could be. Right? And then the fact that it's on the bottom is just even grosser. 1 divided by gross is even more gross. You guys with me? This is not technical speak, by the way. I think you pick one. So, very often in mathematics, we see this as being not simplified yet. Because I So rationalization, what kind of a number is a rational number? Rational. You guys remember? There's whole numbers, natural numbers, integers. Then there's rationals and irrationals. What's the difference between rationals and irrationals? What's the root word of rational? Ratio. So you can write them as a fraction. So square root of 2 is an example of an irrational number. You can't write it as a fraction. You can't make it like 3 over 7. You just can't. There's no way. It's a decimal that never ends. Right? They're gross. So rationalization means make the bottom into a rational whole number. So why can't I not do the square root of 2? Why can't I do that? Square root needs how many inside? Square root needs how many inside? Why can I do the square root of 9? Because 9 has 2 3's. So square root needs 2 of something inside. And right now it's only got 1. So the beautiful thing, rationalization, what I call it is completing the root. Completing the root. What does this guy need in order to be done? He needs 1 more 2. So give it to him. There you go, buddy. So why can't I do this? If I do this, it's no good. That 2 can't get inside, can it? It's got to be square root. In fact, another way to look at this is, what is that 2 to the what power?
1/2.
Beautiful, right? So it's like half a 2. So if I give it another half a 2, it should become a whole 2.
So does 2 go on the top then?
Yeah, but whatever do the bottom, I've got to do the top. So I understand when you first see this done, you're like, well, that doesn't look any better. But it's a lot better, because now at least my irrational part is not being divided. That makes it even worse. So what do I get here? 1 times square root of 2, I'll do the top. Yeah, square root of 2 times square root of 2 is square root of 4, which is 2. You knew it was going to come out to be a whole thing. Half of a 2 times another half of a 2 makes, of course, a whole 2. Right? So here, what would happen here then? Give it another 7, right?
Yeah.
So if you give the bottom another 7, you got to give the top the same thing, even if it doesn't want it. It's too damn bad. You just got to, right? And then what do you get? Up to the top. 3 squared 7.
7 over 7.
Over 7, exactly. Because that would be the square root of 49, which is 7. So why even go to that point with the 49? You know that half of 7 makes a whole 7. Now just to freak you out. What do you think about this here? What's the difference here?
3 times.
Cube root. But what was the idea? We said the square root needs 2 things, so I had only 1 2, so I gave it another 2. A cube root needs 3. I've only got 1 5, so I'm going to get it 2 more. That's why I call it completing the root. You give it as much as it needs to complete what this is asking for. Then these are really stupid easy, if you look at it like that. It needs 3, it's got 1, I'm going to give it 2. Right? You can't make that any better.
25.
Yeah, 25. Huh? So you multiply by a cube root of 2 more 5s, right? 5 squared. So on the bottom, what are you going to get?
You get
5. You're going to get 5. You get a cube root of 125. What's even better, you can write it like this. Cube root of 5 to the... No, 5. 1 5 times 2 5s is 3 5s, right? And on the top, I get 7 times the cube root of 5 squared, which is 25, right? So what do I get on the bottom now? What's it better? What does the cube root and the cube do? Cancel. So of course it makes a whole 5. That was the whole reason I gave it 2 more 5s, was so that this could be done. A third of a 5 and 2/3 of a 5 makes a whole 5. So the idea of rationalization is actually, if you let it be simple, it is simple.
Can you go back to that, how you have that on the top, where you had 7 equals 7, and then you have cube root 3, and then 25 inside there?
Well, this is the cube root of 5 squared. Right, I had to give it 2 more 5s on the bottom, so I gave it 2 more 5s. And what is 5 squared? Okay, cube root of 25. Cube root of 5 squared is the cube root of 25.
So So you just got rid of that to a made it 25 and you took the...
I did what 5 squared wanted me to do. Right? If I left this, it's sort of like part of my problem's not done. Don't tell me 5 squared. Don't give me work
So
to
that's
do.
in
You
here.
do the work and I check it. So 5 squared, you got to tell me what it is. Don't say it's whatever 5 squared is. Check. Put what it is. Right? All right. Okay. So that's the idea of rationalization, and I don't think it gets too weird in the work. One last example like this, and then we got tons of time. Good. Let's do something a little bit freakier. So the instructions would say rationalize the denominator. Right, so you can focus on the denominator. So you can either look at it, you can say, okay, it's got 1 9, so it needs 2 more. But what's a better way to look at that? 9 is actually 2 3s. So you can be a little bit more clever about what you've already got. So what more do you need?
1 more.
1 more 3, because it's a cube root. It needs 3 things, so if I only got 2, I'm going to give it 1 more. That's why I like the name completing the root.
So it'd be 27.
Let's find it. So you multiply by cube root of 3, 1 more 3. On the top, we got to multiply by cube root of 3. Now, I made the top just a little bit different now. Every time before, why could I not make this 21? Why can't I make that 21?
Because it's
They now have the same root. But now, what's the difference on this problem? What's cube root of 4 times cube root of 3?
the same root.
Root of 12.
Cube root of 12, I love it. Since they're the same root, I can just put those together. Now what happens to the bottom?
3.
You get 3. And again, to show you, you will get cube root of 27. Well, what's the cube root of 27? 3. So you know the bottom, if you did correctly, the bottom should become rational. Even better, it should be a whole number. That's your goal when you're trying to rationalize the denominator. Right? Sorry, I like our source thing right there.
What about wasn't cube root of 3 off?
Oh, what if that was like a 5th root or something? Then on the top of it would be 5th root of 4 times cube root of 3. You couldn't slam them together, right? Does that make sense? I mean, the only reason I was allowed to put them together is because they were the same root. So if somebody put a 5th root up there, you can just put 5th root of 4 times cube root of 3. Just leave it like, because you can't do anything else. It's sort of like if I say add x and y, and you go, x plus y, I'm done. Because you can't do anything with them, right?
So what happens if you have cube root of 4 and then divided by a 4 and put it at 9?
So if I had cube root of 4 over the 4th root of 9,
Right.
alright, so how many more whats do I need? 2 more 3s, because I already have 2 3s. So I'm going to multiply by what here? 4th root of
9.
9. I need 2 more 3s, right? So now I'm going to have 1, 2, 3, 4 3s. So I'll be able to do this. Maybe a little bit better, just write 3 squared, right? I need 2 more 3s. So what do you multiply the top by? Do you have a choice?
No.
No! Once you establish that, it's got to be the same damn thing up there, right? Can I put these together?
No.
No, it's cube root, it's the 4th root. So on the top, I'm going to get cube root of 4, 4th root of 9. That looks yummy, but, you know, what the hell can I
So
do?
it's just like saying x plus y.
Exactly.
Okay.
It's just like x, y. If I had x times x, it's a squared. If I have x times y, that is x, y. I can't do anything. Yeah, and on the bottom, I'm going to get 3. Right? I have 2 fourths of 3, and 2 fourths of 3 makes a whole 3. Or I can say 4th root of 1, 2, 3, 4. 3, 4. Of course, these cancel. So I get a 3 on the bottom. So that's rationalization. Before I let you out of here, I want to see what you think about this. 2 problems. We start off nice. Oh yes. But don't overthink this. How do you solve equations? You're always doing the opposite operation.
Which is square root, right?
So what's the opposite of a square root? power of what?
1/2.
2. It is a 1/2 power. The opposite of a 1/2 power is a second power. So if I square both sides, what will happen to the square root? Now, why do you think I'm doing that? Yeah, where is the x currently? Stuck inside the root. So the first thing I want to do is kill the root. So if I square both sides, why am I squaring both sides? Because it's the opposite of what's going on. So watch this. If I had x plus 1 over 7 equals 2, what would you do first? Yeah, kill the thing that's got my x stuck. My x is stuck on top of the 7. Let me kill the 7 by multiplying. Why did I multiply? Because it's the opposite of divide. So why did I square? Because it's the opposite of square root. So now what do these two do to each other? Cancel. So what am I left with here?
X plus
Look at that. Freed by x.
and 4.
4. So x equals?
3.
Yeah, minus 1 minus 1. Craziness. Too bad, right? I told you 2 problems. You got to keep in mind word. Now, what's different here? What do you got to be careful about here?
We have to move 2.
Beautiful. So here's the thing. This is like political science class. You want to be a dictator of a country? Isolate the radical element and then kill it. Right? Yes. Get the 2 out of the way first. Make it look like this. This was easy because there's no extra pieces anywhere. So I want to first get this. I want to get where my variable is alone. I want to get the 2 out of it. Because if I square it right now, that would so zestfully suck. You want to foil that? I'd rather get 2 the hell out of the way. And then I got square root of this equals 5. And then what can I do to both sides?
Multiplying or raising 0.
Yes.
You can't add it?
I can't break into the square root.
Oh.
Plus 5 would just be that plus 5.
Oh, okay.
I have to square it first, so I free this stuff up. Alright. Alright, that's plenty. So that's section 12.6. I had to do something brand new today. Jesus Cristo.
So the rational